Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will have another Q&A session. And today's topic is about water conning and water breakthrough. And we will use Sobocinski and Cornelius method to perform the calculation. Okay, so now we have the case in front of us. This case is from Tarek Ahmed book, the Reservoir Engineering Handbook. It's a very interesting and important book. So I recommend you to read it. So this is the case. Calculate the water breakthrough using Sobocinski and Cornelius method for a vertical well producing at 250 stock time barrel per day. The following reservoir data are available and we can read the oil flow rate, or the flow rate is 250 stock time barrel per day, and the reservoir thickness or oil column thickness H 50 feet, and HP is the perforated interval of 15 feet, and water density, you can see we have also the oil density, oil viscosity, oil formation volume factor. So we have the PVT data. If you don't know, if you don't have this value, you need to perform PVT analysis. You need to read the PVT report or fluid properties analysis report, and you will have the data. And we also have permeability, horizontal permeability of 93 millidarcies. And fortunately, we also have vertical permeability of 9 millidarcies. So the anisotropy or the permeability ratio Kv per kH is somewhat or close to 10%, a typical value. And we also have the porosity, 13%, and M is the mobility ratio of 3. Okay, so interesting. In this case, M is greater than 1, so it means water will be more mobile compared to the oil, unfortunately for us. Okay, so as usual, we will put down all the data into our data table. I've prepared my data, parameter, symbol, the value, and the unit. So let's populate the data. Flow rate is 250 stock barrel per day. Oil column thickness H is 50 feet. Horizontal permeability 93 millidarcies. Vertical permeability 9 millidarcies. Porosity 13%. And let me take the symbol first. Insert symbol, and let's find our porosity. There you go. Oil density 47.5, whereas water density 63.76, and oil viscosity 0.73, oil formation volume factor 1.1, mobility ratio of 3, dimensionless, and perforated interval HP of 15 feet. Okay, so I'm gonna hide. So let's go to the solution. I've prepared the solution, and let me put the data table first. Okay, and okay, copy and put it there like this. And I want to connect this sheet with the previous sheet. So instead of having the value here, I will just erase them and then connect this sheet using this, connect to this table. Okay, so it's like this. So every time I have other cases, I can just delete my case here and put the new case and change the data here. It will automatically connect it to this solution sheet. Okay, so it's just to be more practical and to be more handy. Okay, so this is going to be very quick. So let's solve it. We have 3 steps. The first one is we need to solve for the dimensionless cone height. By the way, to perform this, you need to first remember or understand the concept of Sobocinski and Cornelius method for the water breakthrough and water conning. And I assume you already know that. Okay, so first we need to calculate dimensionless cone height Z. Let's do this, or maybe, okay, like this. So Z, okay, this will be dimensionless, equal 0.492 e to the power of minus 4 multiplied by density difference. In this case, water density minus oil density, and then multiplied by permeability, horizontal permeability, multiplied by oil column thickness, and then multiplied by oil column thickness minus perforation interval, okay? And then everything divided by open parenthesis oil viscosity multiplied by oil formation volume factor and then multiplied by oil flow rate or flow rate. Close. Okay, so it's 0.65, okay, or 0.6486. Let me color it. Okay, so this is our dimensionless cone height. Very easy. I'm gonna borrow this one. And then the second step, calculate the dimensionless breakthrough time. And fortunately, it's very simple. Okay, we can calculate the dimensionless breakthrough time or TDBT in straightforward fashion. I just put like this. So let's type in TDBT. Again, it's dimensionless. And let's use the formula there. 4 multiplied by Z plus 1.75 multiplied by Z squared, and then minus 0.75 multiplied by Z to the power of to the power of 3, and everything at the nominator, you put them inside the parentheses and divide it with 7 minus 2 multiplied by the dimensionless cone height or Z, like this, and then close. So you have it. You have the TDBT or dimensionless breakthrough time of 0.5481. I just want to use maybe three decimal figures instead of 4. Okay, or maybe you can maintain 2 decimal figures after comma. Okay, so the last thing, estimate time to breakthrough. Okay, so after you start producing your vertical well in this particular reservoir, you start the production, day 0, start the production, and then you will wait for how many days until you will have the breakthrough, until the well experience breakthrough. So we already have the dimensionless cone height and then dimensionless breakthrough time. Now we just simply calculate estimate time to breakthrough. And in this case, we are going to use M or water oil mobility ratio. If you don't have the value, you need to calculate it using this. But fortunately, we already know our mobility ratio, so we can skip this part. Okay, so let's calculate it. Now just call it TBT. And the formula there, 2325 multiplied by oil viscosity there, and then multiplied by H porosity and TDBT. So multiplied by reservoir thickness and then porosity and then TDBT. Very easy. And then you put everything at the denominator into one group and then you divide them with open parentheses, open again, density difference, vertical permeability. So density difference will be water density minus oil density, and then you multiply them with vertical permeability, and then multiply it again with something here. So 1 plus m is the mobility ratio, and close again. Okay, and we still need to calculate the alpha. Okay, so alpha I can borrow, or maybe here we need to calculate alpha first. I'm going to use Excel formula. So first, let's borrow the symbol first. Let's find alpha there. Okay, so the rule is alpha. Okay, will be 0.5 for m below 1, 0.6 for the m between 1 and greater and less than or equal to 10. Okay, so how we are going to put it? Okay, let me borrow this first. So maybe we can put like this first, m, and then call m from the data table, and then we can click if logical test. If this less than equal to 1, this will be 0.5. If not, it should be 0.6. It's simple formula. So it's like this. So m will be 1. Okay. If this one, wait, 0.5, logical test, if this equals to or less than 1, the value will be 0.5. If it is between 1 and m and n10, it should be 0.6. So actually alpha will be 0.6, and then we just put the alpha there, power by 0.6. Okay, but maybe you can notice something wrong here. It's too long. Okay, this will be days. Okay, it's too long. Yeah, let me do like this first. It's too long. Why? Because the porosity here, we wrote it in a way like this, 13%, where actually the value is not 13 but 0.13, okay, in fraction. So actually we can do like this. It should be the porosity, which is located at E9, should be divided by 100 first, like this. And then there you have it. So the breakthrough time is 123 days. So in the day number 123, after you start producing this vertical well from this particular reservoir, you will experience breakthrough. Okay, so the water cut will increase to a certain value from previously pure oil, no water. Okay, so maybe I can say like this. So from the very start of the production to the day 122, the end of the day 122, you will have 250 stock tank barrel per day of oil without water. But after the day 123, you will start producing water. Why? Because you experience water breakthrough. Okay, from the bottom water in this case. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next Eng-Man videos. Thank you.